Yes, madam.
Right. Thank you. Okay, we are going to have a lecture of DAPM 11063, which is Agri-Food Product Manufacturing and Value Chain. So today we are going to talk about plant-based food processing and logistics management. So specifically, we are going to talk about fruit and vegetable processing and value addition. I'm Geeti Pamunwa. I'm a senior lecturer of the Department of Horticulture and Landscape Gardening of the Faculty of Agriculture and Plantation Management. So let's look at now, we are going to talk about processing and preservation. So why do we have to process and preserve? Because foods undergo deterioration. They decay, foods. They decay and they are affected by so many factors. So they lose their ability to be a food, actually. Because if the food is, say, infected with microbes, if they produce toxins, and if the microbes are bad to us, we don't want to eat the foods anymore. So now foods undergo deterioration and losses. So we are going to talk about those things now. First, so what are the contributory factors for food deterioration and losses? So one is chemical changes. Chemical changes can be either enzymatic or non-enzymatic. Chemical changes, rasayanikava siduna venaskam. So they can be either enzymatic or non-enzymatic.
Recording in progress.
So do you know what enzymes are?
Yes.
All of you? Please let me know if you don't know what enzymes are.
Enzymes are protein.
Yes. Proteins. And what do they do, enzymes?
Induce the reaction of.
You're partly correct. The word is not induce. I think it's accelerates. Enzymes accelerate the chemical reactions. Right? There are, plenty of reactions do not take place fast enough. Right? So they do not take place fast. They can stay for many years sometimes without reacting with each other. Reactants can be like that. So what the role of enzymes is to bring a So what enzymes do is that they make the reaction occur fast. They bind to the reactants and make the reaction happen fast. So that is the role of enzymes, right? Enzymes they play a catalytic role. They make reactions happen fast, right? So that is what enzymes are, right? So these chemical changes that take place can be either enzymatic, that is, some chemical changes are catalyzed by enzymes, and there are certain other chemicals which are not catalyzed by enzymes. I mean, enzymes are not involved in those chemical reactions. So there are two types, enzymatic changes and non-enzymatic changes. So we will look at what enzymatic changes are and what non-enzymatic changes that we are talking about when we talk about food deterioration. So both enzymatic changes and non-enzymatic changes affect many properties of foods, chemical properties and physical properties, and also the sensory quality changes. For example, lipid oxidation. If lipid oxidation happens, we will not like to consume that lipid anymore. So I will come to that later. Now, one example is rancidity, which is mudu වෙනවා කියන්නේ තෙල් මුඩු වෙනවා. So if oil has gone rancid, we don't want to use that in food. And there are non-enzymatic browning reactions. Browning reactions not involved where enzymes are not.
Caramelization.
I'm sorry?
Caramelization.
Yes, that's one example. That's correct. Non-enzymatic browning. Caramelization is one example. And also there is another example, which is Maillard reactions. So caramelization takes place when there are sugar. When there are sugars, caramelization takes place. So these Maillard reactions take place when there are proteins and sugars together. And color reactions and flavor changes also take place due to both enzymatic and non-enzymatic reactions, and nutritional quality can go down. Nutritional quality. And there can be many physical changes. Yes, all enzymes are proteins. All enzymes are proteins. There are other things that catalyze reactions, but they are not called enzymes. When we call enzymes, they are proteins. And nutritional quality and many physical changes can take place. Bruises and damages to fruits, vegetables, and many physical changes. The color can change, and there can be many physical changes that take place that leads to food deterioration and losses. And also many changes are brought about by microbes and animals. These are living organisms. So those things also affect food deterioration and losses. So let's talk about enzymatic changes first. Now, enzymes endogenous to plant tissues. So that means plant tissues have enzymes. I mean, we don't have to put enzymes. Plant tissues already have enzymes. So those are called endogenous enzymes, right? Plant tissues already have enzymes, and the changes brought about by enzymes can be either desirable or undesirable. That is, sometimes we want those reactions to take place, and sometimes we don't want the reactions to take place. Sometimes we want to stop the reactions or delay the reactions. So effects of endogenous enzymes, post-harvest senescence and spoilage. So what is that? So when we remove a fruit from the plant, or if we take a vegetable, those are still living systems. They do respiration, so they take oxygen, emit carbon dioxide, and they do transpiration. So water vapor comes from the fruits and vegetables. So they are living tissues, and there are, so as I mentioned previously, there are enzymes in plants and vegetables. So so they undergo changes. So if we take, for example, a mango, so initially it will be green in color, and then it will turn yellow when it is ripe, and then the fruit will become softer. And if we eat if we cut the mango when it is green, what happens? It will be
The pectinase.
Yes, one of the reactions that comes under number 4, softening of plant tissues during ripening, that is catalyzed by pectinases. The pectin is, I'm talking about number 4 now. Pectin is the substance that gives firmness to fruits, and so with time, due to the action of pectinases, this pectin can undergo some chemical reactions. Actually, they undergo a demethylation reaction. Because of you don't have to worry about that. These enzymes, pectinates, change the enzyme, the pectins in the fruits, and because of that, the tissues become softer during ripening. Right? So I was talking about number 1, post-harvest senescence and spoilage. So if we take a mango, let's take that mango, it becomes yellow. And if we cut it, it is sweet. But if we take a mango that is not ripe enough, it can be sour and it will not have a sweet taste. And also, so that is post-harvest senescence and spoilage. Ultimately, if we don't eat the mango, it will rot and we will not be able to eat it anymore. Then there can be microbial attack and we won't be able to eat it anymore. And there is another thing called enzymatic browning. That is another reaction that is brought about by enzymes. So do you know about enzymatic browning? Okay, tell me what happens when we take a slice of apple from the fruit. What happens to it?
Become brownie.
Yes, the surface becomes brown, and that is because of
Polyphenol oxidase.
That is right. The enzyme polyphenol oxidase catalyzes a reaction. You don't have to worry about the reaction, but it is polyphenols getting oxidized to form brown color pigments, brown color complexes, right? So polyphenols get oxidized due to the action of polyphenol oxidase. So that is another role of endogenous enzyme. And starch sugar conversion. So starch. So when we take a banana, if we eat it unripe, we won't get a sweet taste. It will be starch only. But with time, due to the action of enzymes, the starch gets converted to sugar, and because of that, we get this sweet taste. So those reactions, and also softening of plant tissues, we talked about it previously. So those changes are brought about by enzymes endogenous enzymes, which are already there. And we actually want these reactions to take place. So we want this, we want the fruit to ripe. And yeah, enzymatic browning, of course, we don't want. We want starch to get converted to sugar. We want to make the fruit soften so that they are ready to eat. But over-ripening is not good. We want, to a certain extent, we want some enzymatic reactions to take place, but we don't want to make those reactions happen too fast. When we take, say, a banana, fruit එකක් ගත්තොත් අපිට පුළුවන් වෙන්න ඕනේ. එතකොට මේ reactions අපි වෙනවට අපි කැමති. දැන් banana එකක් ripe වෙන්න ඕනේ. Mango එකක් ripe වෙන්න ඕනේ. මේ reactions අපිට ඕනේ වෙන්න. But if we want to, but sometimes we want to increase the shelf life. අපිට මේක දවස් 5කින් නෙවෙයි සමහරට අපිට 20කින් වෙන්න අපි try කරන්න පුළුවන්. මොකද that is because we want sometimes to transport fruits and vegetables to distant places. And after transporting also, we want the fruits and vegetables to be in good quality. Right? Because of that, we want to delay certain enzymatic reactions. So we can do many things to change the enzymatic activity. So one is temperature, water activity, temperature. Sometimes like a fruit at 25 degrees Celsius and a fruit at 40 degrees Celsius, if we compare ripening of those two things, the fruits at two different temperatures, we will definitely see that the fruit at 40 degrees Celsius will ripen fast. So the temperature is affecting, but if we increase the temperature to 60 or 70, that will not be a good thing. That is, the temperature is too much. So that will harm the fruits and vegetables. But if we increase the temperature a little bit, and if the temperature is around 40, I think, it will give a good effect. 40 or slightly below 40, it will give a good effect. I mean, the reaction will happen fast. So if we want to make the fruits ripen slowly, then we might choose a lower temperature. Sometimes we can go up to 15 degrees Celsius. But I'm sure you have experienced that if you put a banana in the fridge, what will happen?
Freeze damages.
Chill damages, yes. If we put it in the fridge, chill damages take place. Chilling injuries take place. So that is what I wanted to highlight, was that we can reduce the temperature and make these reactions happen at a slow rate. We can do that. But sometimes we don't want to decrease the temperature too much also. For example, if we take banana, we can't keep it at 4 degrees Celsius. We can't keep it in the refrigerator. The temperature can be 15 degrees Celsius or so. So we have to think of the fruit, and each different fruits can be lowered to different levels. Sometimes we can't use these fridges or 4 degrees or 5 degrees. They will need a higher temperature, but still the temperature can be lower than the temperature of the room temperature. Yeah, due to these enzymatic reactions, many other changes also occur in fruits and vegetables. I just took now these 4 examples, the most common reactions that take place, right? And so yes, temperature we can decrease. If the room temperature is 25, we may be able to decrease the temperature to 15 in the case of banana, right? So apples, we can decrease the temperature to, I think, about 4 to 8 with no problem. So we have to consider the different fruit and vegetables when we decide on the temperature to increase the shelf life. And then water activity. Water activity. So all of us know that like enzymes are proteins and they are soluble in water, right? They are soluble in water. They are stable in water. So when the water content or water activity increases, so now if the fruit or vegetable is very dry, then enzymatic reactions will not take place. For example, if we take dehydrated fruit or vegetables, right? Dehydrated fruit or vegetables, in those things, enzymatic reactions do not take place. But so enzymes need water for the enzymes to catalyze reactions. So if we have enough water, then enzymatic reactions will take place successfully. And this water activity is related to some other thing as well, like microbial growth. For microbes also, water activity is very important, right? So for enzymatic activity also, water is important. And the pH. Different enzymes function best at different pHs. Right? So there can be certain enzymes that function best at pH 4.5. And there can be other enzymes that have that function best at pH 7. Did you understand that point? For different enzymes, the optimum pH is different. Did you understand what I said?
Yes.
Okay, right. Thank you. And chemicals that can inhibit enzyme reactions. So there can be chemicals of banana, but both the fruits undergo enzymatic browning. So they turn brown. They turn brown fast. So we can't actually make a fruit salad early and keep it. We can't do it because those fruits undergo browning. So what we can do is that we can dip the fruit pieces in a citric acid solution. Okay, and then after some time we can take the pieces out And then we can incorporate banana pieces and apple pieces in the fruit salad, and you will be able to keep it for some time, right? For a considerable period of time. So if you invite your friends for dinner, normally if you want to give fruit salad, you'll have to prepare it after dinner, just before eating the fruit salad. But if you use this citric acid, using citric acid, you can prepare it beforehand, and then so it will be okay for 2 to 3 hours if you dip the fruits in citric acid and take it, right? Then you will be good. Right, that was an example of chemicals that can inhibit enzyme reactions. So citric acid affects the chemical structure of enzymes. And because of that, enzymes cannot do their function properly. Any questions up to this point?
Madam,
Yes?
starch sugar conversion එකට Maillard reaction එකද ගන්නෙ?
Starch sugar conversion එකට ගන්නේ enzyme එක ගත්තොත් amylase. Enzyme එක ගත්තොත් Maillard reaction එක කියන්නේ වෙන එකක්. Maillard reaction එක වෙන එකට example එකක් තමා if we take making milk toffee. Maillard reactions rarely occur in fruits and vegetables. Okay? If you take milk toffee, you add milk which has proteins. Actually, proteins are made of amino acids, and amino acids are the ones that are involved in this reaction. There is milk and sugar. So those two can react, and it will give a brown color. It will form brown complexes, right? Brown compounds, polymers. Also, at the same time, caramelization takes place when we make milk toffee because sugar is there. So sugars can react and then caramelize. Is it clear to you?
Yes, madam. අර bakery industry වලදීත් මේ Maillard reaction එක ගන්නව නේද? අර fish bun වගේ.
Right, ගන්නවා. Maillard reaction එක වෙනවා bakery industry එකෙත්, right. Proteins උයි sugar තියෙන ඕනම එක Maillard reaction වෙන්න පුළුවන් heat එක තියෙනවා නම්. දැන් අපි ගත්තාම meat වර්ග අපි ඒවා දැන් අර grill එක දාලා roast කරන මේ heat කරන වෙලාවකදී වුණත් දැන් අර golden brown color එක එන්න උදව් වෙනවා Maillard reaction එක. Proteins react කරනවා sugars එක්ක.
හරි, thank you, madam.
Right. So then chemical changes. If we take chemical changes, some chemical changes, both enzymatic and non-enzymatic, affect sensory quality of the foods as well. So lipid oxidation, as I mentioned previously, lipid oxidation, non-enzymatic browning, color changes, and flavor changes affect the sensory quality of the foods. Lipid oxidation, factors affecting the rate of reaction. So I gave you one example of lipid oxidation, that is rancidity. So that means foods, the lipidic component undergoes oxidation reactions. That is, the lipids react with oxygen to form many compounds, and because of that, there is this off flavor development, and we don't want to eat those things anymore. මුඩු වෙනවා. පොල් තෙල් වගේ එකක් ගත්තාම අපිට හොඳ එක්සැම්පල් එකක්. මුඩු වෙනවා කියන එක. එතකොට දැන් හැම රියැක්ෂන් එකක් වගේම there are factors affecting the rate of reaction. So these are factors actually that affect almost all reactions, right? One is light. So light actually increases the rate of reactions because light gives energy to the molecules, and light, if the reactants, the substrates are exposed to light, usually the reactions take place fast. And also local oxygen concentration. If we are talking about lipid oxidation, obviously the oxygen concentration has a role to play. If the local oxygen concentration is high, the lipid oxidation rate will also be high. And high temperature. Usually up to a certain point, we can increase the temperature to increase the rate of reaction. So in other words, if we reduce the temperature, we can actually keep the oil for a longer period of time without those oils undergoing lipid oxidation reactions. So this is something that I normally do when I buy coconut oil. I pour the oil to a container, a plastic container, and I keep it in the fridge. So what happens is that it becomes solidified. So now the oil is a solid, but then whenever I want to use coconut oil, I can take a tablespoon and get the amount that I want. So I do that to delay rancidity. I use a low temperature to slow down the reaction. And so in the presence of many metal ions, metal atoms, metals, the reaction takes place fast. For example, iron and copper. If iron and copper are present, these oxidation reactions happen fast. Hydrolytic rancidity, that is now in hydrolysis of triglycerides, right? In hydrolysis of triglycerides, due to these hydrolytic reactions, the fatty acids separate from the glycerol molecule, and that can be called hydrolytic rancidity if it gives foul smells and if it undergoes oxidation. So hydrolytic rancidity means rancidity rancidity that occur as a result of hydrolysis of the triglycerides or diglycerides or monoglycerides. So that happens due to hydrolytic reactions. So if we take lipid oxidation, so any fatty acid can undergo lipid oxidation. Any fatty acid, any lipid can't be all the lipids, but so there should be actually, now I'm telling you, now this is the thing that I plan to explain. Now I'm explaining something that is not be tested at the exam, right? I don't expect you to understand this 100%. If you know these things, that is enough. Okay, now lipids. if they are prone to oxidation, usually if they have double bonds and if the electron density is very high, they are prone to oxidation and they can undergo oxidation. So now lipids prone to undergoing oxidation can actually react with oxygen and form many other different compounds, and they give foul smells, and we will not want to eat those lipids anymore. Lipid hydrolysis is removal of fatty. Now, if you take a triglyceride that consists of a glycerol molecule and 3 fatty acids, so now the bond between glycerol and fatty acid can be broken through hydrolysis. So that is what is lipid hydrolytic rancidity. That is what drives hydrolytic rancidity. But I don't expect you to know those things that I said now. So water activity. So when water activity increases, this breaking down of lipids, as I mentioned previously, hydrolysis takes place, and it can affect the rate of lipid oxidation, rate of reaction. So if we control these factors, we can reduce the extent of lipid oxidation in foods. We can reduce the extent of lipid oxidation in foods. Nutritional quality. So like any other reactions, now the reactions leading to nutritional quality losses can be controlled using these factors. So these are the major factors affecting nutritional quality: light, oxygen concentration, temperature, and water activity. So if we talk about nutritional quality, so let's take one example, vitamin C or ascorbic acid. Vitamin C or ascorbic acid. They are the most sensitive vitamin in foods is vitamin C. Vitamin C, the structure is given here. It is also called ascorbic acid. So it is the most sensitive vitamin in foods, and it is sensitive to oxygen. That is, it gets deteriorated. It gets decomposed in the presence of oxygen. This ascorbic acid breaks down in the presence of oxygen. If we make the pH to a higher pH, and trace metal ions such as iron, copper, like that, trace metal ions, and moisture. So this vitamin C is a very sensitive compound. So the vitamin C is present in dark green leafy vegetables, papaya, citrus fruits, etc. So chemical changes can lead to the loss of vitamin C. And physical changes. So if we take fruits and vegetables, physical damages in the field, even when harvesting, physical damages can take place during transportation, storage, and handling. So I have seen people using wooden boxes to transport fruits and vegetables, and sometimes including tomato, which is very sensitive. So now it's not practical to protect each tomato fruit, but then it is very sensitive too. So because of that, during handling, such vegetables and fruits are very susceptible to get damaged. So what we have to do is that we have to use good handling practices, and also appropriate packaging. I'm sure you have seen these. Sometimes the apples are put in these cushioning like covers with like with big holes. There is this cushioning like material that is used to package apples. I'm sure you have seen that. So likewise, we can use appropriate packaging material to package fruits and vegetables so that they don't undergo physical changes. And if we take a powder such as milk powder, Milo, Nesta malt like that, with time, with the absorption of moisture, they undergo caking. You can see in this picture there are like big now like they're not powders anymore. They have aggregated and formed these like bigger structures, and we can't dissolve the milk powder or Milo or Nesta malt easily when this happens. And also there are many changes that are caused by microbes. So microorganisms found in food can be bacteria or fungi. So if we take bacteria, there are many pathogens and many other bacteria. Examples include Escherichia coli, Salmonella, Shigella, Staphylococcus. And compared to fungi, bacteria grow faster. And if we take fungi, they can be yeasts and molds. So you can see the picture on the right-hand side, yeasts and molds. Yeasts are like, we actually don't, well, sometimes we use yeast. Can you give me an example?
පිපුම් කාරකයක් විදිහට අර මේ ආප්ප වගේ දේවල් හදද්දි කෑමවලදී.
Oh, Appa Hadaddi. And can you give me another example?
හත්තු
මොකද?
හත්තු වගේ දේවල් නෑ නෑ.
Yeast පාවිච්චි කරනවා අපි bread in the bakery industry to make bread. Then yeast වල මොකද වෙන්නේ? Reaction එකේදී carbon dioxide හැදෙනවා. ඒකෙන් තමයි අර bread වල structure එක එන්නේ, porous structure එක. Carbon dioxide evolve වෙන එකෙන් අර පිපෙනවා. dough එක හරියට හැදෙන්න we use yeast. Yes. මේ yeast වල reaction එක තමයි glucose එක react කරලා alcohol and ඒ කියන්නේ ethanol and carbon dioxide හදන එක. එතකොට carbon dioxide හදන එක වැදගත් bakery industry වලට. ethanol තිබ්බොත් ඒව ඔක්කොම evaporate වෙනවා අපි bake කරද්දී. That is one area we use yeast. අනික් එක තමයි to make wine and beer we use yeast. මොකද ethanol හදන නිසා. So those are instances that we want yes. So those are instances that we want we intentionally use yeast. But there can be other instances that we don't want the action of yeast. That is, if we take a beverage, like a normal beverage, fruit juice mixture, fruit juice, or ready-to-serve beverage, then in that case, we don't want alcohol production. We don't want to spoil the spoil the drink. But if we do not process it properly, then these reactions catalyzed by yeast will take place and the juice will not be drinkable as it is anymore. In those cases, we want to kill the yeast. So we use a high thermal treatment, heat treatment to get rid of the yeast. And molds. So I'm sure you have seen this mold growth even on bread. If we don't eat it fast enough, if we keep the bread for about, I don't know, many days, 5, 6, 7 days, we can see mold growth. So black in color usually, but sometimes we get these green colored molds also. So you can see in this picture, a mandarin has undergone this infection by molds. Mold growth on this mandarin fruit is shown. So these microbes, as I mentioned previously, changes caused by microbes can be either desirable or undesirable. So it's desirable when we add as an essential part in food preservation. So those are desirable. And undesirable changes take place when microbes arise unintentionally and subsequently grow to produce food spoilage. So those are the two sides of microbial changes. So types of foods. Based on stability, we can categorize foods into 3 groups: perishables, semi-perishable, and shelf-stable. These definitions are not like strict. We can roughly use these definitions. So perishable items are not processed or minimally processed. So have you seen, can you give me an example where you have seen these minimally processed fruits and vegetables?
Mushroom.
Mushroom is, yes, not processed, right? It's packaged. What else? Have you seen
Fresh
the,
fruits.
yes, fresh fruits? I mean, fresh fruits and vegetables, yeah, they are of course not processed. That's true. Fresh fruits and vegetables are not processed. So those are perishable items, right? I want some examples of minimally processed, like processed but not heavily processed items.
Pasteurized milk.
Well, that is true. Can you give me examples of fruits and vegetables? Minimally processed? Can you give me an example where you have seen processed but minimally processed?
blanch කරපු vegetables
කොහෙද තියෙන්නේ?
අර noodle එක්ක එහෙම තියෙන්නේ.
Minimally processed noodles වල? Hari, now have you seen in supermarkets when you go to the cashier? Usually you have these styrofoam plates where cut fruits are placed on the trays and covered with cling wrap. Covered with cling wrap, have you seen that? අර supermarkets වල වගේ cashier එක ළඟට යද්දි එතන තමයි normally තියෙන්නේ. styrofoam පොඩි tray එකක කපලා fruits තියලා අර cling wrap එක wrap කරලා vegetables උත් එහෙම තියෙනවා. දැකලා තියෙනවද? minimally processed.
No.
දැකලා නැහැ? I think you should go to I'm sure you have gone to a supermarket, but you haven't observed this. You haven't observed this, I think. චුට්ටක් ගිහිල්ලා බලන්න කීල්ස් එකට වගේ ගිහිල්ලා බලන්න දැකලා තියෙනවද කියලා? මේකෙත් තියෙනවා. කාගිල්ස් වලත් මම දැකලා තියෙනවා මේ පොඩි trays වල දාලා cut ඒවා minimally processed. මොකද wash කරන්න ඕනේ, peel කරන්න ඕනේ, කපන්න ඕනේ. හොඳ shape එකකට නැත්නම් size එකකට සමහර ඒවා citric acid වල dip කරන්න ඕනේ. ඒ කියන්නේ processing එකක් වෙලා තියෙනවා. නිකම්ම raw fruits and vegetables නෙවෙයි. processing එකක් වෙලා තියෙනවා but minimally processed.
අර කොහිල පෙතිත් ඒ වගේද පැක් කරපු?
කොහිල පෙතිත් තියෙනවානේ. ඔව්. කොහිල පෙති මම දැකලා තියෙනවද කියලා මට ෂුවර් නැහැ. කොහිල පෙති තියෙනවා නම් ඒකත් එහෙම තමයි. හැබැයි එහෙමනම් බ්ලාන්ච් කරන්නවත් වෙයි කොහිල පෙති තියෙනවා නම්. බ්‍රවුනින් නතර කරන්නත් ඕනේ. දැන් සාමාන්‍යයෙන් instant soup එක මොනවද තියෙන්නේ? ඇතුලේ තියෙනවා dehydrated vegetables. soup එක තියෙනවා dehydrated vegetables. එතකොට dehydrated vegetables minimally processed එකක් නන් නෙවෙයි. When it comes to not processed or minimally processed items, the qualities of the fruits and the vegetables are very similar to the unprocessed material. Very much similar to the unprocessed material. Right? So the qualities is largely retained, but if we take dehydrated vegetables, the quality is drastically changed. So that is not minimal processing. That is true processing, not minimal processing, right? So the shelf life is smaller than 60 days. Examples include vegetables, fruits, meat, and milk. So forms of processing can be washing, peeling, packaging, storage under low temperature, like that. And there are semi-perishable foods where the shelf life is between 2 to 6 months as a result of mild preservation methods. So those preservation methods include, examples of semi-perishable items include pickled vegetables, ice cream, cheese, eggs, root crop. So if we can keep it for 2 to 6 months, those are called semi-perishable items. And the other end is shelf-stable items. The shelf life is greater than 6 months. So at room temperature. Examples include dehydrated vegetables. So dehydrated vegetables come under shelf-stable material, because if we dehydrate vegetables or fruits, we can keep the dehydrated items for a very long period of time if we do packaging properly. So that is a shelf-stable product. And canned food. So how about this salmon? What is the shelf life? Have you noticed? How long can we keep salmon?
When it will be open?
Without opening, how long can we keep? The can, how long can we keep? I think it's 3 years. It's 3 years. The shelf life of salmon is 3 years. So, yes. And then canned food, cereal, grain, of course, dehydrated pasta, frozen food, and nuts. So, what we can identify is that after opening, they become perishable. Greater than 6 months. After opening, of course, we have to, after opening, we have to eat it or use it. After opening, because of the packaging and the treatments, only that we can keep it for such a long time, right? They can become perishable under certain conditions. Faulty seams of can. So if cans, that is, if the cans are not sealed properly, then the food will not be shelf stable. They can be perishable. Right? So many other like microbes can enter and many other reactions can take place. So then what is inside will be perishable.
Recording stopped.
Right. We will have a 10-minute break and then come do the lecture again. 10-minute break. So the shelf life of different food products. So we learned about perishable foods, semi-perishable foods, and shelf-stable foods. So the shelf life of different food products are given here. Different food items are given here. At 21 degrees Celsius, meat, 1 to 2 days, fish, 1 to 2 days, poultry, 1 to 2 days, fruits, 1 to 7 days, can be kept. Fruits, of course, can be kept for some time. Leafy vegetables, 1 to 2 days. Then root crops, 7 to 20. And look at this, dried, salted, smoked meat, greater than 1 year. Dried fruits, greater than 1 year. And vegetables, greater than 1 year. And dried seeds, greater than 1 year. Effect of animals. So due to animals, of course, food deterioration and losses take place. So some examples are given here. Insect pests. So one example is tomato worm, and then brinjal fruit borer are examples. And then there can be bigger animals such as rodents, rats, squirrels, and chipmunks affecting foods. So these rodents are very, so we have to think of these rodents very attentively, because their feet can contain microbes that are pathogens. So we have to, like, if we see that some food is eaten by rodents, we should actually throw it.
කෘන්තකයින්ද මැඩම් මේ
Ah,
කෘන්තකයින් කියන මෙයාලටද
මම ඒ සිංහල ටර්ම් එක නම් දන්නේ නැහැ. sorry මම සිංහල ටර්ම් එක දන්නේ නැහැ මේකට. rodents කියලා තමයි දන්නේ. We have to be very careful because කට්ටියගේ මේ feet එකේ මේ pathogenic microbes ලා තියාගෙන ඉන්න පුළුවන්, so we have to be very careful. So now let us look at the introduction of food preservation. So horticultural produce, so this is what we focus actually in this lecture. Fruits and vegetables, very essential, giving a lot of nutrients and fiber necessary for the human health. So importance of fruits and vegetables. They are rich in vitamins and minerals, and also they contain fiber and carbohydrates. So they are two, I mean, they are called foods of low biological value because that is not something that is bad actually. That is not bad. Right? Now, low biological value keyword buy වෙන්න දෙයක් නැහැ. The meaning of that is that vitamins with essential amino acids is less. Right? But we don't eat fruits and vegetables to get proteins. Proteins with essential amino acids is less. That is what is meant by low biological value. හරිද? ඒ කියන්නේ යම්කිසි ආහාරයක protein, දැන් අපි essential amino acids කියලා જાතියක් කතා කරනවානේ. ඒ කියන්නේ proteins හැදිලා තියෙන්නේ, they are made of amino acids. Proteins are made of amino acids. And in our body, we can synthesize most of the amino acids, but there are certain amino acids that we can't synthesize. Right? So those amino acids that we can't synthesize should be taken in through food. Okay, taken in by the form of foods. So that is why we want to take food that has proteins. Then essential amino acids අපිට බෑ synthesize කරන්න අපේ body එකට. එතකොට ඒ essential amino acids වැඩියෙන් තියෙන food එකට අපි කියනවා high biological value එකක් තියෙනවා කියලා. Essential amino acids අඩු ඒවට අපි කියනවා low biological value එකක් තියෙන food එකක් කියලා. It is okay. ඒ කියන්නේ අපි කිසිම නරකයි කියනව නෙවෙයි. Proteins නැහැ ඉතින්. ඒ essential amino acids තියෙන protein නැහැ. But fruits and vegetables are rich in vitamins and minerals and fiber and carbohydrates. Right? So they are essential to us, fruits and vegetables. So if you look at the picture on the left-hand side, you can see that now if we take different fruits and vegetables, we can get almost all the vitamins. If we take different fruits and vegetables, we can get all the vitamins that are necessary to us. And also here on the table on the right hand side, you can see that if we take vitamin fruits, like different fruits and vegetables, we can get not only vitamins, but we can get minerals too. Right? So fruits and vegetables are very essential to us, and apart from vitamins and minerals, they contain fiber, which is very important for the proper functioning of the gastrointestinal tract. Right? And then carbohydrates, yeah, important. Of course, in the form of starch or sugar, we get carbohydrates from fruits and vegetables. Processed fruits and vegetables. So you can see these different types of pictures, very attractive. So all these foods are made of fruits and vegetables. So we are going to talk about these things now. Here on the top left-hand corner, you can see different types of fruits and vegetables pickled. We will talk about pickling, pickled fruits and vegetables, and then different types of, I would say, fermented beverages, unfermented beverages, and many other items such as, I think, just jam and things like that made of fruits and vegetables, jellies, and then dehydrated fruits and vegetables, and also canned fruits and vegetables. So this is very, very convenient to use something like that. If we, for example, I'm talking about the picture on the bottom right-hand side corner. So this is very convenient if we don't have enough time, and if we want to make a fruit salad. So we can just take this tin, open it, and use the fruits inside. Usually fruits are in a sugar solution. Why process or preserve? Now, tell me, why should we process and preserve fruits and vegetables? Why? Can you give me some reasons?
Seasonality of fruits.
Right, because certain crops are seasonal. If we want to eat fruits and vegetables throughout the year, we should process and preserve. That is right. What else?
They are perishable.
Yes, perishable. Then why do we have to process and preserve? Yes, to increase the shelf life. To control enzyme reactions, right? That is to increase the shelf life, right? To control enzymatic reactions, right? What else?
For value addition.
For value addition, that's correct. What else? Control chemical reactions, right? What else?
For distribution.
That's right. Right. So let's look at to increase demand. That's right. Right. Let's look at the answers. Stop microorganism. Yes, right. Stop microorganism activity to increase the shelf life. Why process or preserve? To extend seasonality. So we talked about it, right? Allow consumption in regions distant from the growing region. because we can actually eat an apple that was made in Australia. So through processing and preservation only, we can do that. Sometimes there may be foods that are made in other countries, but for us to consume it, processing and preservation is important. Okay? Otherwise, we won't be able to eat something that is made in Australia or America or England or Japan. So processing and preservation is important because now it takes time to transport a food from a place to another place. So the shelf life should be long enough so that the a distant region, people in a distant region can eat it. And prolong shelf life and arrest deterioration during storage. By controlling the enzymatic reaction, controlling the chemical reactions, not allowing microbes to grow, we can increase the shelf life and stop deterioration during storage. And improve the nutritional quality and digestibility of some foods. It is told that, do you know sauce? Tomato that is used in. Have you heard about it? It's told that now these tomatoes have a bioactive compound which is called lycopene. It's called lycopene. It has antioxidant properties, anti-cancer properties, like different properties. So this lycopene is more absorbable when we make ketchup or sauce, rather than eating the fruit, the tomato alone. Like the unprocessed tomato can be eaten, but then the absorption of lycopene to the body is less. If we make sauce out of tomatoes, then we can absorb lycopene better. Right? So we can improve nutritional quality. Nutritional quality can be improved through processing, not all the time, in certain instances, and digestibility of some foods, digestibility. So this is obvious, right? When we processed foods, the digestibility increases. If you take a guava, පේරගෙඩියක් ගත්තොත්, when we can eat it raw, and you said something for enhancing microbial. Yes, now when processing and preservation, for example, if we take heat processing in pasteurizing milk or sterilizing milk, making ready-to-serve beverages, we use heat treatment, and using heat treatment, we destroy microbes. So we can enhance the microbial safety and also chemical safety of foods. Then allow for long-term storage in case of drought and famine. So long-term storage. Then අපි shelf life එක වැඩි කරනවා because of that. නියං කාලවලදී එහෙම නැත්නම් සාගතයකදී පාවිච්චි වගේ පුළුවන් if we actually preserve food. That's very important. And increase the variety and desirability of food. That is adding value, and it was mentioned previously. Now, if we take mango, we can eat mango raw. Apart from that, what can we make?
Pickle.
I'm sorry. Yes, pickle. We can make pickle and what? Chutney, right? Right? I'm sure you know the answers, even though you don't say those things. Cordial, right?
Pickle.
Jam.
Yes, jam, pickle, right? What else?
Sauce.
Sauce, right? Using mango, I don't know whether there is mango sauce. I'm not sure about that. But of course, you get the idea, right? We can make many foods, many food items, jams, jellies. You mentioned those things, chutneys, pickles, cordial, nectars, many other things can be made, right? We can make canned mangoes, like we can eat the same thing in different ways, right? So that can be done. Improve quality control and provide more consistent product. What does it mean? Improve quality control and provide a more consistent product.
Prevent some hazards like disease.
Right, that is true. I think here what is meant is slightly different. Improve quality control and provide a more consistent product. Can you give me an example of a consistency of a product?
Maldives fish වල අර powder එක.
හරි අපි මෙහෙම හිතමු. දැන් ඕගලන්ට සමහරට මේක ඉච්චර බලපන්න නැතුව ඇති. දැන් මම දැන් කන මාරි බිස්කට් එකයි මම පොඩි කාලේ කාපු මාරි බිස්කට් එකයි එකම වගේ. ඒක තමයි consistency කියලා කියන්නේ. ඒ වගේම මම මෙතනදී පැකට් එකක් ඇරලා කෑවත් වෙන බැච් එකක් හදපු මාරි බිස්කට් එකක් කෑවත් රස එකමයි. ඒ කියන්නේ ඒ කට්ටිය consistent එකම විදිහට එකම control එකේ qualities control කරලා හදනවා products. හරිද? Then if we take for example mango juice, then හිතමු හරි mango juice නැත්නම් mango ready to serve beverage. Do you know what ready to serve drinks are? Do you know what ready to serve drinks are? දන්නවනේ දර මේ අපි usually we call it smack එකක් කියලා කියන්නේ. අපි drink එකක් අපිට කඩලා ඒ වෙලාවෙම බොන්න පුළුවන් juice එකක්. කියන්නේ ready to drink. ඒවට කියන්නේ. Ready to drink. දැන් මේක fruit juice based. Ready to drink. හරිද? දැන් එහෙම අපි ගත්තොත් mango, එහෙම නැත්නම් pineapple ගත්තා කියමු. ඒතර හැම drink එකේම පාට එකම වගේ. ඒ වුණාට අපි different අපි mangoes ගමු different mangoes ගත්තලා අපි ඒ වෙන වෙනම juice එකක් හැදුවොත් එකම පාට නෙවෙයි තියෙන්නේ. එක කොටසක් කහ පාටට බරයි, තව කොටසක් orange පාටට බරයි. එහෙම එකම color එක නෙවෙයි තියෙන්නේ අපි නිකන් හැදුවොත්. දැන් මෙතන improve quality control and provide a more consistent product කියන්නේ quality එක. ඒ කියන්නේ අපි color එක ගත්තොත් එකම color එකකට අපි ගන්නවා. color එක මදි නම් colorants දානවා මොකක් හරි කරලා අපි එකම කියන්නේ consistency නැත්නම් quality control අපි color එක මේක වෙන්න ඕන නම් ඒකට අපි adjust කරනවා. pH එක acidity මේක නම් අපි ඒකට adjust කරනවා. sweetness මේක නම් ඒකට adjust කරනවා. එහෙම අපිට දැන් processing and preservation වල එකක් තමයි අපි quality control කරලා අර more consistent product එකක් අපි එළියට දානවා. අර batch to batch උනත් variation එකක් නැහැ. දැන් අපිට improve කරන්න ඕන නම් අපි වෙනම හදලා improve කරන එක හරි. නමුත් එහෙම නැත්තම් මොකක් හරි set qualities අපි define කරලා තියෙනවා නම් ඒකට හරියන්නම හදනවා. batch wise උනත් ඔක්කොම. ඉතින් ඒ කියන්නේ අර අපිට එකම රහ දැන් මම කිව්වා වගේ මාරි බිස්කට් එකේ මට එකම රහ හම් වෙන්නේ මේ අර quality control කරලා සමහරට ඒ කට්ටිය decide කරලා ඇති මාරි බිස්කට් එකේ නම් තව improvement එකක් ඕනේ මේ රහම තමා කියලා. size එක වෙනස් වෙලා තියෙනවා gold මාරි කියලා. නමුත් රසයේ වෙනසක් වෙලා නැහැ. ඒ කියන්නේ ඒව quality control කරලා එකම product එකක් විදිහට හදනවා. ඒක කරන්න පුළුවන් මේ processing and preservation වලින්. අපි ගෙදර හදලා juice එකක් බිව්වොත් මේ අඹ ගෙඩියකින් හදන එකයි තව අඹ ගෙඩියකින් හදන එකයි රසවල් දෙකක්. Do you understand what I mean by this point? Improve quality control and provide a more consistent product. Yeah, no, neither. Did you understand what I meant? Do you understand that point? You can drop a message on chat. Do you understand? Right. And then the next point is permit extraction of key nutrients for health and medicinal uses. Yes. By processing and preservation, process or preserve. So using processing, we can extract after processing. We can extract key nutrients from products. Then let's take a fruit. Let's take a fruit such as what? Okay, let's take a hypothetical fruit. So we have to wash it, we have to cut it, we have to peel it, and then we have to cut it, maybe reduce the size of it, and then we can extract key nutrients. හරිද? එහෙම අපි කපලා සමහරවිට අපි dry කරලා මේ ජලය අපිට අවශ්‍ය medium එකක් නෙවෙයි නම් අපි dry කරලා චූටි කැලි වලට කපලා dry කරලා අපිට පුළුවන් nutrients extract කරගන්න. එහෙම එකක් කරන්නත් පුළුවන්. අනිත් එක තමයි there can be byproducts of fruits and vegetables. For example, if we take a tomato product, sometimes the peel of tomatoes will be a byproduct. But the peel has lycopene that I mentioned previously. Peel එකේ lycopene තියෙනවා. එතකොට ඒ byproduct එකෙන් අපිට lycopene extract කරගන්න පුළුවන්. Right? So that is permitted. That is permit extraction of key nutrients. Then the next item is enhance convenience and reduce preparation time prior to consumption. I mentioned this previously. So I showed these these canned mixed fruit So then if we don't have time to make a dessert, we can just, like, if we don't have time to go shopping, wash, peel, and cut, if we don't have time to do that, we can just take a can of mixed fruit and then use it in a for example, in a fruit salad. Also, suppose you want to make upside down pudding using pineapple. You have to make a pudding using pineapple, but you don't have time to buy pineapple, wash and peel and cut. You don't have to remove the core. Don't have time, so you just can take a pineapple chunks, a can of pineapple chunks, and then use it. So it's very convenient, and it reduces preparation time. And some cases reduce cost of fresh horticultural products. So sometimes, like to take to transport fresh horticultural produce for a long distance, it takes money, because we have to give sometimes cold condition, maintain cold chains. So if we have like new processing and preservation techniques, we might be able to reduce the cost of fresh horticultural products. So there are many methods of food preservation that have been used since ancient times. So one is drying. So this is a very common technique that has been used from ancient times. So drying can be done to preserve fruit, vegetable, meats, and fish. So drying can be done very successfully in southern warmer climates. So when there is snow, or when there is no sunlight, if the climate is very humid, drying cannot be done successfully. But drying is good, but then drying causes the loss of many natural vitamins. So many natural vitamins can be degraded due to drying. Another historic method of food preservation is salting. So salting is done extensively for meat and fish. Dry fish, I'm sure you have eaten dry fish. Karavala. So it has been salted and then dried. So sometimes salting is done for fruits and vegetables too. One example is mango salting and drying that has been practiced in Sri Lanka for quite some time. And billing, salting, and boiling is also is an example. Then apart from salting, sugaring has been done. So examples include jams, jellies, and marmalades. So we are going to talk about those things. So we have to add a lot of sugars to make the fruits preserved in jams, jellies, and marmalades. And there are other food items such as pumpkin preserve, that is puhuldosi, pumpkin preserve, and then garlic in bees honey, and those are examples of sugaring. Historic methods of food preservation continued. That is, another thing is pickling. So pickles. So pickles can be fermented pickles or unfermented pickles. In fermented pickles, we let microbes such as lactic acid bacteria grow. Because of the lactic acid that is produced, then like harmful bacteria cannot grow in that medium. In fermenting. In unfermented pickles, we add vinegar mainly. We add vinegar, and because of that, now vinegar is acetic acid, the pH is brought down, and because of that, again, the microbes cannot grow. So pickling is done mainly to preserve vegetables. So we add a salt. So we dip the vegetables in a salt solution. So it can reduce the vitamin content, but then due to the growth of microbes, other vitamins can be introduced into the food as well. So pickling is the oldest form of food preservation using microbes. Cold storage. Now this is done mainly during the winter season where snowing, where like a winter period, in winter season. And in Sri Lanka, we don't have a winter season, but we can use wet gunny bags. In the winter season, now it's very convenient because now fridges will be there at houses, but then outside it, all the cars, vans, and all the vehicles and all the garages will be like fridges or freezers, right? So we don't have to actually incur money to maintain fridges or freezers during that period. So in this lesson, in this session, we are going to talk about many preservation methods. Now I'm giving you some examples of the preservation. One is thermal processing. We will look at cooking, blanching, pasteurization, sterilization, and frying. So those are examples, those are methods involving thermal processing. And cold processing, we can do refrigeration and freezing as cold processing methods. And dehydration, this is very important because this is a method that has been used since ancient times, but still it's a very popular method. So we are going to talk about that too. Candying and crystallization is something very interesting. We can talk about that. Fermentation. So we came across this word fermentation. It involves transforming a substrate into a different product through the usage of microbes. So in for example, wine production, the substrate is like sucrose or glucose, which is converted to alcohol through the use of yeast. And addition of chemicals is something that we are going to talk about. And then atmosphere composition. So do you have any idea what this means, atmosphere composition? Atmosphere composition. Atmosphere composition. So I would like to mention two things under atmosphere composition. One is, now imagine a storage facility. So imagine a storage facility. So this is the room, the storage facility. So you have kept, say, racks of different fruits or vegetables. So you can actually maintain the gaseous composition of this storage facility. So we know that fruits and vegetables are living tissues. They do respiration. They take oxygen in and yes, MAP packaging. Right. I will come to it. So we can, this is a storage facility, right? A big room or a big hall or something like that, a big storage facility. So we know that fruits and vegetables are living tissues. They do respiration. They take in oxygen and emit carbon dioxide. So if there is plenty of oxygen, that is very good for the fruits and vegetables. They can breathe very easily and they can undergo the metabolic reactions fast. But we don't want that to happen. We want to extend the shelf life. So what we can do is that we can reduce the oxygen content and increase the carbon dioxide and nitrogen content. So we know that normally in the atmosphere, we have about 21% of oxygen, 79% of nitrogen, and 0.03% of carbon dioxide. When I was small, that was the ratio, but I'm sure it has changed now. But let's think that is the ratio, correct ratio. So what we can do is we can reduce. So instead of having 21% of oxygen, we can reduce it to 15%, increase the carbon dioxide percentage and nitrogen percentage to make the balance, right? But we can't. So in that case, what will happen is now oxygen is not easily, not that available to the fruits and vegetables. So because of that, the fruits and vegetables do respiration at a slower rate. And because of that, the metabolic reactions of fruits and vegetables will, the speed of the metabolic reactions will go down. But we can't actually make the oxygen content zero. We can't do that. There is a maximum limit to which we can reduce the oxygen content. Because we want fruits and vegetables to breathe. We want that to happen. So if we make it zero, or if we make it too low, what will happen is anaerobic respiration will take place. If that happens, these unfavorable flavors and unfavorable compounds can be formed in the fruits and vegetables. So again, that is not good. But what we want is to reduce the respiration rate. So we can reduce the oxygen content, not to make it zero, right? So, so what I was telling is here, we can actually make the oxygen content, let's say, for example, 15%. We can increase the nitrogen content. It was 79, we can make it, say, 83. And we can make the carbon dioxide presentation 2%. So make it there. Right? So we can, but now we can make the, and we can make the temperature, let's say 10 degrees. And then we can maintain these conditions, but with vegetables and fruits being live tissues, they do respiration. So we can see a decrease in oxygen content and increase in carbon dioxide content with time. But we don't want that to happen. We don't allow that to happen. We maintain. We have sensors for the three gases and temperature, of course. So when this indicates that the oxygen content goes down, we can actually make it automated to increase the oxygen content back to 15%. Likewise, there can be sensors and we can maintain the gas composition in this whole storage facility. So that is called controlled atmospheric, I think, atmospheric storage. Or I'm not sure, atmospheric or fear storage. Right? So this was a whole facility, a big facility. And we can do something called modified atmosphere packaging. Modified atmosphere packaging, which is called MAP. In modified atmosphere packaging, we are not talking about the whole facility, but we are talking about a small package. We are talking about the small package where the product is put. Product made of fruit or vegetable is put here. The product is here. And there is this small space filled with air inside the package. So the gaseous composition in the air inside the package can be changed. So we can change the composition, say 15% oxygen, 83% nitrogen. We can change it, right? During packaging, we put these things. 2% carbon dioxide. Another difference between modified atmosphere packaging and controlled atmosphere storage is that in controlled atmosphere storage, we control this percentage. We make this thing constant. But in modified atmosphere packaging, we are not going to do it. We can't make this constant. With time, there can be respiration and transpiration or many other chemical reactions. And this will change slowly. Not drastically, but slowly these ratios will change. We are not going to do anything about it. So that is called a modified atmosphere packaging. So is this clear to you? Is this clear to you? Yes, madam. Clear, right? Right. This is about atmosphere composition, and then irradiation can also be done. Irradiation can also be done. That is, we can use high energy radiation, such as gamma radiation, X-rays, like radiation, and then we can destroy the pathogens, microorganisms, and also if there are insects, worms, so we can preserve the food using irradiation. We are not going to talk much about it. And there are many other modern preservation techniques. Some are at research level, but now this high pressure, magnetism, cosmic, laser rays, electricity are some example. Now this high pressure processing is very commonly used in Western countries. So what is done here is that the pressure of a food item is increased by putting it, like first packaging it and putting it in water or something like that. The pressure is increased, and because of the high pressure, microbes get destroyed. Sometimes enzymes get destroyed, and when we release the pressure, normally the food comes back to its original state. So that is about high pressure, but we are not going to talk about that in this. So because we are not using heat treatment, this high pressure is very giving very good sensory appeal. I'm told that now there is this high pressure processed apple juice juice is available in Australia. So not like the normal apple juice we have. So that has a slightly brown color because of the polyphenol oxidase reaction, and some properties are changed because of this heat treatment. But if we use high pressure processing for the processing of apple juice, then the qualities will much retain, and it is like biting into an apple when we drink the apple juice. So now let's look at the principles of food preservation. So we saw that there are various types of various causes of deterioration of food. We talked about chemical reactions, physical changes, and then microbiological changes, animals. Likewise, there are many causes of food deterioration, and by curbing those factors of causes of food deterioration, we can preserve the foods. And there are many different methods of food preservation. So under principles of food preservation, we are talking about preventing or delay of microbial decomposition of food. So we can actually curb microbial decomposition. Also, prevention or delay of self-decomposition of food. Self-decomposition can be done by chemical reactions, enzymatic or non-enzymatic chemical reactions. And then the damage caused by insects, animals, and mechanical causes can be prevented. And by that, we can we can preserve the food. So we are talking about preventing or delay of microbial decomposition of food. Prevention or delay of microbial decomposition of food. So we can hinder the growth and activity of microorganisms. We can hinder, we can stop, we can slow down the growth and activity of microorganisms. So how can we do it? We can actually we can use low temperatures, and we can dry the food commodity so that the microbes can't grow, because I told you previously that for microbial growth, there should be moisture or water. So by drying, we can get rid of the water, and because of that, drying will take place. And by creating anaerobic conditions, a lot of microbes need oxygen for survival. If we create anaerobic conditions, that is oxygen-free conditions, those microbes won't be able to grow. And also we can use chemicals by use of chemicals. So let's talk about hindering the growth and activity of microbes by using low temperature. So microbial growth and enzyme activity are retarded by storing food at low temperatures. Right? So these are some examples. Cellar storage. So you can see cellars on the top right hand side, the picture on the top right hand side. So to store root crops, potatoes, onion like that, we can use this temperature, 15 degrees. And refrigerator or chilling temperatures, normally 0 to 5, but we have, I think, refrigerators of which the temperature is 4 to 8, but this is okay, 0 to 5. And we can put most fruits, vegetables, meat, poultry, fresh milk, and other milk products like yogurt, curd, cheese-like products. And then freezing temperature, minus 18 to 40 degrees Celsius. We can have different types of foods such as frozen peas, mushrooms, etc. And what are the different types of food that comes under freezing temperature? If you go to a supermarket, what do you see in the freezer?
Meatballs, sausage.
Right, meatballs, sausages, what else?
Ice cream.
Ice cream, right? And now there are frozen baked products too, such as different naan and Arabic bread and like mini and regular pizza, frozen pizza. Those items are also there. Actually, French fries, right? Frozen. And there are different wraps like spring wraps and things like that we can fry and take. So those things are there. And frozen like shorties, rolls like that, samosa like that, frozen items are there. And actually I make pizza at home using Arabic bread. There is Arabic bread, so we can take Arabic bread and so if we have different onion, tomato, and some toppings, and then we can use mozzarella cheese, and in a pan we can make pizza if we buy Arabic bread. That's a cheap way of making pizza at home. Rather than making the dough myself, I prefer Arabic bread. So the point is many different types of foods are stored at low temperature, refrigerated temperature and chilling, freezing temperatures. And we can hinder the growth and activity of microbes by doing that, and the shelf life is increased. Then by drying a food commodity, so as I mentioned previously, like to grow and multiply. So if we dry the food commodity, we remove the water from the food to a level at which microorganisms fail to grow, right? There are many ways of removal of moisture. We can do sun drying and mechanical drying. So we will be talking about these things shortly. We can do sun drying and mechanical drying. I'm sure you have seen sun drying. We normally do that, sun drying. So even when we have like, what is rice, cooked rice, and if we have that in excess, we dry it, cooked rice, and then make aggala. So that is sun drying. We use sun drying to do that, and there are many other things that we do. And mechanical drying is where we use specific equipment for drying.
Solar dryer.
solar, right? One example, right? And then examples are dried grapes, that is raisins, apricots, onion, cauliflower, etc. Now, this drying has become a very useful techniques now, because now most of the time people tend to go for fruits and vegetables instead of fried things. So, like for snacks, some people take dried fruits instead of fried things, right? Dried fruits are taken. I have tasted apricots, dried apricots, very tasty. I don't know whether they import apricots here, but very tasty. So for a snack, that is very good. That is healthier than using fried items. And also that was using heat, we can dehydrate. And also by using, by binding the moisture with addition of sugar. So when we add sugar, what happens is that water molecules form bonds with sugar. So water molecules can't participate in other things, such as they don't, for example, they don't make a good medium for the microbes to grow. We can bind moisture with addition of sugar, such as jams, jelly, salt, like in raw mango. So what happens is, because we have put a lot of sugar, if say for example, we hypothetically we put a microbe, so what happens is that water from the microbe goes out and sugar comes in, so that the microbe dies. So that is called osmotic dehydration. Okay, I'm going to
Recording stopped.
okay, I'm going to give you a 10-minute break now. 10-minute break, and then we will receive 10-minute break.
Recording in progress.
Yes, now under preventing or delay of microbial decomposition, another thing we can do is to kill the microbes. So how can we kill the microbes? I'm sure you are very familiar with these things. Pasteurization, that is heating below 100 degrees Celsius, boiling, heating, that is heating at 100, and then heating above 100. So we can use this heat treatments to kill the microbes. And also, as I mentioned previously, we can use irradiation, X-rays, gamma rays, like that, accelerated electrons to kill microbes. Use of heat, pasteurization. Grape wine, so is pasteurized. Fruit juice is pasteurized. Beer, vinegar are some examples of pasteurization of products, fruit and vegetable products. Then we can do another thing, because we can okay, now we talked about microbial decomposition of food. The methods were to kill the microbes, to hinder the growth and activity of microbes, right? So those were the techniques. And now we are going to talk about prevention or delay of self-decomposition of food. Self-decomposition. So one thing that we can do is, so we saw very clearly that there are endogenous enzymes, and because of the action of the endogenous enzymes, food decomposition can take place. So by destruction or inactivation of food enzymes, we can delay self-decomposition. An example is blanching or boiling. So blanching, it's a mild heat treatment given to vegetables before canning, freezing or drying. So to prevent self-decomposition of food by destroying enzymes. So I'm sure you have heard this term blanching, because one of you very clearly told about blanched vegetables. So do you know anything about blanching? Do you know anything about blanching? Now, what we do in blanching is we want to inactivate the enzymes, right? So the enzymes can be, right. We can do two things. One is hot water blanching, and the other one is steam blanching, right? So by using either hot water blanching or steam blanching, we are destroying the enzymes, right? So So now hot water blanching is shown here on the picture on the left-hand side. So blanching is carried out by dipping the food commodity either in boiling water or by exposing them to heat for a few minutes, followed by immediate cooling. We want to kill the microbes, that's true, but we don't want to cook the food too. We actually, if we can retain the natural properties of food, that's the best, but it will not be so because we are dipping the food, like in this case, beans in hot water. Some changes will take place, but we don't want to completely cook the food, the vegetables too. So we actually dip it in, so in this case, dip it in boiling water for few minutes, for I think 2 to 3 minutes, 2 to 5 minutes, and then we immediately put it in ice cold water or water at room temperature, preferably ice cold water, to prevent the heat in the beans from cooking it. We immediately put it to ice cold water. We can steam the vegetables too, but after steaming again we put it in ice cold water because we don't want to completely cook the vegetables. And also we can delay chemical reactions. Now previously we talked about enzymatic reaction, so we can delay chemical reactions as well. We can use antioxidants to prevent oxidation, because we actually previously also talked about oils getting rancid, going rancid. So if that happens, in order to prevent hydroxyquinone, lecithin, etc., right? We can use those things to prevent oxidation reactions. So other methods, as I mentioned previously, low temperature, low humidity, low oxygen, and dark conditions to slow down oxidation reactions. We can put, one thing is we can put antioxidants, or else we can use other methods. So now let's look at how we can prevent damages by insects, other animals, rodents, and mechanical causes. We can use fumigants in dried fruits, cereals, to reduce the damage caused by insects and rodents. Fumigants. දුම් ගහනවා කියන්නේ අපි දුම් ඒ වගේ පාවිච්චි කරන්න පුළුවන් වෙන fumigants. Right, so one is that. The other one is wrapping of fruits, providing cushioning trays using light pack and good packaging materials checks the damage to fresh food commodities during handling and transportation. So we talked about tomatoes, and there are other types of like mandarins that can get damaged easily. So we have to provide cushioning trays to prevent mechanical damage, handling and storage. And also we have to use good storage facilities. Cushioning trays, I'm sure you have seen those things, like for eggs we have these trays, and it's very difficult for me to explain, but there are like sheets like that made of pulp, which can be used as cushioning trays for fruits. Right. So now
Recording stopped.
Right now we are going to talk about fruit and vegetable products. Right. Now, let's first talk about fruits. They are nearly all acidic, high acid fruits. Normally, fruits are acidic. An exception would be banana. I think some forms of banana are not acidic, but most of the fruits are acidic. If you take papaya, mango, pineapples, so those are very acidic. Now, this acidity naturally controls the type of microorganisms that are able to grow in food products because of the acidity. Now, if you take a ready-to-serve beverage, ready-to-serve drink, the pH is less than 4. So, since we maintain that pH, it's difficult for most microorganisms to grow in that product. Likewise, if you take a fruit product, only microbes that can grow at very low pHs will grow on the fruits. Otherwise, they won't grow. Then the spoilage microorganisms that are likely to be found in such products are molds and yeasts. Usually, mold and yeast can grow on, as spoilage microorganisms can grow on fruits. But these molds and yeast usually do not make us ill, right? And by processing and preservation, using sugar, salt, vinegar, and by dehydrating, concentration, or fermentation, we can preserve the food products made of fruits. So if you take vegetables, they are less acidic than fruits. So vegetables are low acid products. There is no acidity, like fruits are much more acidic than vegetables. A wide range of microorganisms can grow in low acid products, and those microbes can easily spoil the vegetables because they are low acid products. The acidity is not high. So in order to prevent this from happening, so we can do many things. We can use heat treatment to destroy bacteria. We can do pickling, salting, drying to inhibit bacterial growth. So, since these vegetables are low acid foods, like many bacteria, yeast and molds can grow, and we have to be very careful because we don't want to transmit poisoning bacteria to consumers. So we have to be extra careful when we process and preserve vegetables. So we will look at a few products. One is fruit products. First, let us look at jams, jellies, marmalades, and fruit cheeses. So jams. So as you can see on the picture on the left-hand side, many different types of jams. Strawberry jam, apricot jams, blackberry, raspberry, peach jam, like different types of jams are there. So in Sri Lanka, we commonly have mango jam, pineapple jam, orange jam, and mixed fruit jam. So I took this picture, MD mixed fruit jam, from the website. And the ingredients of this mixed fruit jam are pineapple, mango, pawpaw, passion fruit, and lime. Of course, they have put pectin and citric acid. Citric acid to adjust the pH and pectin to make it firm, the jam. So to call it a mixed fruit jam, at least there should be 4 fruits. So it is okay. Pineapple, mango, pawpaw, passion fruit, lime. There are 5. Jams are a solid gel using fruit pulp or juice, sugar, and pectin. Jams will be made from single fruit or a combination of fruits. So in mixed fruit jams, so this is a mixed fruit, right? So in the label, the first named fruit should be at least 50% of the total fruit added, right? First named fruit. So here, then the ingredients should start from pineapple. So that means pineapple is at least 50%. So in the picture also, you can see that pineapple is the largest fruit here. This is based on the European legislation, and the sugar content of jam should not be less than 68% to prevent mold growth after opening the jar. So you can see how much sugar is added in preparing jams. 68% is needed. So when you have, I think 100 grams, 68% is sugar. Because then only mold growth after opening can be prevented. Any question up to this point? So in jams, to prepare jams, we can use fruit pulp, right? So when it comes to jellies, can you see a difference? I think this picture on the top right-hand corner should be deleted. It is not a real jelly. The jellies are given here on the pictures. On the left-hand side, Smuckers, strawberry jelly and Concord grape jelly. So what is the difference between jellies and jams? What is the difference between jellies and jams? So in jellies, we can use fruit pulp and it is not transparent. We can see that they are solid now. These are not transparent. But when it comes to jelly, they are very transparent. These are crystal clear jams produced using filtered juice instead of fruit pulp. They are using fruit juice and then add sugar and pectin to make this jelly. Very transparent. It's like jam. The only thing is that jam uses fruit pulp. Here they are using fruit juice. Can be used on bread as a spread. Can be used as a spread on bread. I think here in Sri Lanka, we don't normally have jelly. We have jam. And marmalades. As you can see now, it is made of orange or any citrus fruit. And then there are these skin, like the peel, shreds of peel. And there can be various types. This is sweet orange marmalade. I'm not sure we have marmalade. Usually, yeah, there should be marmalade here. This MD lime marmalade is there. The ingredients are lime juice, lime peels, sugar, and pectin. Now for other like sweet orange marmalade, I'm sure the ingredients are orange juice, orange peels, sugar, and pectin. So normally now this skin has sometimes a bitter taste. So it can be, we can get rid of this white part, which gives the bitter taste, white part, we can remove it. Or we can heat the peel separately and take it, heat the peels in water and then take the peel so that the compounds giving bitterness will go away with the water. And we can take it, right? Orange. It's like jam. Yes, this is also like jam. Can use as a sandwich spread. Very tasty when it's sweet. And marmalades produce mainly from clear citrus juices and have fine shreds of peel suspended in the gel. Commonly used fruits include limes, grapefruits, lemons, and oranges. Citrus fruit may be used alone or in combination with ginger. Sugar content is similar to jam, that is 68%. Fruit cheeses. These are highly boiled. Now it's like jam. Fruit cheeses are like jam, but the final sugar content is very high. It goes from 75% to 85%. And because of that, it becomes a block, a solid block. The sugar content is so high that it comes as a solid block. So what we can do is we can cut into bars or cubes, and we can have small pieces and can be used in confectionery and baked goods. Any question up to this point? So production stages for some food preserves: prepare raw material. We have to prepare raw material and use pulp or the extract. Sieve it if we want to have the juice, we have to sieve it and strain. Otherwise, just by sieving, we can have the pulp. If we strain, we get the juice. And we have to add other ingredients, boil to remove the water, and then fill and pack. These are the steps that we have to follow in making jams, jellies, marmalades, and fruit cheeses. Now let us look at chutney, pickles, and sauces. Can be made from a number of fruits and vegetables. So I'm sure you know chutney, pickles can be made from a number of fruits and vegetables, and their accompaniments to meals. The basic principle of preservation is the use of acetic acid. Now, in jams, jellies, and marmalades, the basic principle was to use sugar. Now, here in chutney, pickles, and sauces, the basic principle is to use acetic acid to lower the pH to prevent microbes from growing. And yes, acetic acid preserves the product by making the environment acidic. And by doing so, it inhibits the growth of spoilage and food poisoning microorganisms. So other ingredients such as salt and sugar add to the preservative effect. Chutney. It's like jam. The only difference is that chutney has vinegar and spices. And in chutney, we don't use the pulp, we use small pieces of the fruit. So now in chutney, we use a high sugar content and it has a preservative effect. And also, because of that, we don't have to add a lot of vinegar because of the sugar, it is already preserved. And because of that, we don't have to add a lot of vinegar. And hot filled when it is hot. And usually used fruits in the preparation of chutney are mango, pineapple, amberella, date and lime, date and tamarind, mixed fruit. So those are some common chutneys that we have in Sri Lanka. Let's look at now. I have put certain pictures. Mango chutney. There is this, I can't read the name here. And then tomato chutney is there. And here, spiced beetroot chutney is also there. So they have used some vegetables too in making chutney, because you can add sugar and add vinegar and get the correct taste. So chutney, again, I took this picture from the internet. Umbrella chutney. Ingredients are umbrella, sugar, vinegar, spices, salt. Very simple. Right? So we can have, sugar, vinegar, spices, and salt. Those are the ingredients. Then we will talk about pickles. Pickles can be either fermented or unfermented. I think I mentioned it previously. Pickles can be fermented or unfermented. Sweet or sour can be made from either whole or chopped fruit. In certain cases, we can use the whole fruit if the fruit is small. So now I got this picture of mango pickle from the internet. The ingredients were mango, vinegar, salt, and then mustard, chili, sugar, ginger, garlic, pepper, turmeric. A lot of spices, vinegar and table salt and sugar. So those are the ingredients. And we have many types of pickles in the market: brinjal pickle, lime pickle, Malay pickle, mango mix pickle. Many other types of pickles are there. Sauces. They are thick liquids made from pulped fruits and vegetables with the addition of salt, sugar, and vinegar. Require pasteurization, fill white hot. Why does it need pasteurization? Because in sauce and ketchup, the pH is not as low as that in ready-to-serve drinks or something like that. The pH is higher. It's a liquid. There is a lot of water, and we add vinegar, but not that much. And because of that, we have to pasteurize sauces before, like, to make it before putting it into the market. So these ingredients of just chili sauce include tomato paste, water, sugar, chilies, salt, vinegar, tropical spices, and permitted preservatives. Here also there is tomato. Since they are using tomato paste for the sauce, they have added water, tomato paste and water. Here in ketchup, they have added tomato, but because of that, there is no water, because tomato contains a lot of water. Sugar, salt, vinegar, stabilizers, permitted preservatives. Well, in ketchup, as you can see, they have put stabilizers, which is not present in sauce. That is because ketchup is thicker than sauce. Ketchup is thicker, and that is why I think they are using stabilizers here. Any question up to this point? So pasteurization. If we take pickles, they have adequate preservation index. Because of that, they do not have to be pasteurized. As an additional safety measure, we can boil in pickles, right? We can boil the vinegar mixture and add it to the vegetables, right? Because we are using a hot mixture, a partial vacuum in the jar is created, and because of that, it will prevent recontamination and growth of aerobic microbes. Did you understand that? right? And because we are in sauces, but they have to be pasteurized before filling using a stainless steel pan or a steam jacketed pan, right? So after filling also, we can actually have the lid loosely on top of the container, and we can put the bottle in boiling water and keep it for some time for pasteurization and to get rid of all the air bubbles inside the sauce. So filling and packaging. So now chutneys, pickles are bottled the same way as jams. So we normally use glass jars to put like pickles and chutneys. And if we talk about pickles, and also not only pickles, even sauces, we can have small quantities in polythene pouches, small sachets. We can have small sachets. So we can use a double pouch. In the inner material should be a food grade material. Outer pouch can be made of a cheaper polythene. So I'm sure you have seen these things when you go to a restaurant. Sometimes we are given sauces in small sachets, pouches. We have to tear it and take what is inside out. Also, if you go to Pizza Hut, we get the small sauces in small packets like that. So I'm sure you know what I mean here. Right. Dehydrated fruit and vegetables. So you can see this picture of dehydrated fruits, very eye-catching, different colors. We can identify what those things are. So in dehydration, what we have to keep in mind is that we can't get the original color or the shape, obviously. Size, the appearance changes, the taste changes, but still they become a good, I think now, an alternative snack and can be used in many food products. So dried vegetables. So again, very colorful, and it has been tried. I'm sure they have tried to maintain the original color as much as possible. So where do we get dried vegetables? Some of you mentioned in the first part of this lecture, dried vegetables.
Blanch.
I'm sorry?
Blanching vegetables.
Yes, vegetables should be blanched before dehydration. That is true. That is to destroy the enzymatic action and to preserve the color. That is true. Yeah, but what I'm asking is, where do we find dried vegetables?
Noodles.
Yes, noodles, such as Maggi noodles, or not only Maggi, these kottumi and like that. They have sachets that we have to put, and in the sachet, in the content, we see small pieces of dried vegetables, carrots and leeks. I have seen, right? I'm sure you have seen too. When we cook it gains, it becomes like softer, but of course it doesn't get the original shape, I guess, because they are so small also. So where else? Soups. What else? No, noodles, and also in soups. Instant soups, we have dried vegetables. Instant soups. Because by the addition of water, we can actually make the dried vegetables softer, and they will absorb water and the size will increase, but the dried vegetables will not gain the original shape or the size or appearance. Well, drying is good. Using the sun, light, it has many advantages because now sun drying is a traditionally understood technology. Little or no fuel cost, little or no equipment cost. There are three things that we have to think of when we dry foods, because drying is affected by these things: airflow, temperature, and humidity. If the airflow is fast, then drying happens at a faster rate. So we actually know that, right? Even if we put a cloth on a hanger and then put it in exposed to sunshine to dry, for it to dry, if we have wind, then the drying rate is high, and air temperature, if the temperature is high, the rate of drying is high, and air humidity. If the humidity is high, then the rate of drying will drop. If the humidity is low, if there is less moisture in the air, then the rate of drying will increase. So the relationship between the three is important if drying is to be successful. So in drying, what happens is that we reduce the moisture content to a certain level at which the microorganisms can't grow. And because of that, we can preserve the dried fruits and vegetables. So if the climate is humid, the dried fruits and vegetables can absorb moisture, and again, they will be prone to spoilage. Right, dried fruit and vegetables. Now, there is this dried and fried product as snacks that is also possible. On the left-hand side, we can see dehydrated banana chips. And also on the right, we can see dried and fried vegetables. So I'm sure you have eaten dried fruits. I'm sure you have eaten breadfruit chips. With
honey?
I'm sorry?
With honey?
Yes, with honey, and sometimes we put sugar syrup on it, right? Sugar syrup, and when the syrup cools, it is like a crystal, like crystals on top of the breadfruit chips. It's very tasty. And then we can do osmotic dehydration. Yes, manioc, del, banana, we can use all those things to make dehydrated products, and we can eat it in various ways. I have eaten it with this Chilean salt too. Chilean salt has, if we put Chilean salt and then mix it, again it gives a nice taste instead of sugar, but sugar is the best. So osmotic dehydration can be done. So what is done here is we have a thick solution usually a salt, usually a sugar solution. And when we put the fruit or vegetable into it, what happens is that the water comes out and then the solute, sugar goes in. Because of that, the water content of the food goes down. So because of that, the microbes can't grow. And then let's look at some notes on dehydration, drying. The color change may occur. Because of that, we can do blanching. Drying techniques, we can do drying in the open air, either on mats or in raised platforms. We can use mats on the ground or we can have raised platforms. The problems are food quality and contamination. If we do it like using open air, well, dust and animals like birds and other types of various types of animals can contaminate the foods if we use just open air. As a solution, we can use solar dryers, direct or indirect or combined dryers. So the situation gets better. Then we can use dehydrators, fuel-fired or electric dehydrators. So if we use those things, we can control the parameters that affect drying well. For example, we can control the temperature, airflow, humidity. Like that, we can control the parameters so that drying occurs better. So packaging of dried fruits and vegetables. We can use traditional packaging materials, baskets, jute sacks, and wooden boxes. So these are actually good if we want to take large quantities to a central marketing place and then sold loose. If that's the thing that we have to do, we can use traditional packaging materials. So these can be used several times and they are cheap. But the problem is if the humidity is high, these are not good because then the moisture content of the food can go up and as a result, mold growth can take place. There are advantages of using boxes because we can prevent crushing of dehydrated foods. And so, but if we have humid climates, as I mentioned previously, these traditional packaging materials are not that good. In those cases, we have to use moisture-proof flexible films. So some semi-moist foods such as osmotically dried fruits have special needs to prevent the reabsorption of water. So these osmotically dehydrated fruits can reabsorb water, and then if that happens, they will be, if they absorb water, then the microbes will be able to grow on the food. And then what we have to understand is that dried fruits are very valuable products because we actually spend a lot to make dried fruits, fuel costs, manpower, like the cost of the foods, etc., time. So they are valuable products, and because of that, we actually, it's very unadvisable to lose the products because of not packaging them properly, right? So it's very worth spending more on the package. So we have to use moisture-proof seal bags to package the dehydrated fruits and vegetables. Fruit preserve and fruit candy. So you can see this candied peel, shocho preserve, pumpkin preserve, ginger preserve. I'm sure you have heard about this ginger preserve very much. And even this candied peel, chocho preserve, pumpkin preserve, we actually use those things when we make fruit cake, or I don't know, that's called not rich cake and wedding cake. We use those things. And there are fruit candies. You can see this candy, this citrus peel, and then glazed candied fruits, and again candied fruits, different types of candied fruits. Candied citrus peel. So we have to pack the peels in 15% salt solution and sulfur dioxide. But nowadays sulfur dioxide is not used that much. We try our best to remove this addition of sulfur dioxide. It comes as sodium metabisulfite or potassium metabisulfite. We actually use the minimum amount that is necessary. And then peels are boiled so that we get tender peels. And then candied. The peels are candied. How are they candied? First, we are using a sugar solution of low strength, such as 15% of sugar. We keep it, boil and keep it there for about 1 day. And then we put 25%, then we put 35%, like that. We slowly increase the strength of the sugar solution. And finally, I think they go up to like 55. I'm not very sure, but I think you get the point, right? We have to increase the sugar strength gradually. And then finally, these candied peels are dipped in saturated hot syrup. Saturated, more than 100%. 100%, more than 100% hot syrup. And then when they're dried, we can see sugar crystals on the peels, sugar coating. So that is what is done in the preparation of candied citrus peel. Glazed fruits. So we take candied fruit. So now you know how to make candied fruit, and dipped in thick sugar syrup, right? So first we take the candied fruits. That is, we increase the strength of the sugar solution gradually. And then we actually dip the fruits in thick sugar syrup and we dry it. After that, we dip it in 1.5% pectin solution and then dry it again. So when we dry the product, now because of pectin, it gets a very attractive, shiny appearance. Then we can have crystallized fruit. As usual, we have to do candying. That is, we increase the strength of the sugar solution. And then because of that, so we can increase and if we use a saturated hot solution, finally, on drying, we will be able to see these sugar crystals forming on the surface. Alternately, we can actually do a sugar coating from rolling the fruit candy on sugar. We can do that too. We can make the fruit candy and we can roll the fruit candy on sugar. Right. Now let's look at fruit beverages, juices, and powders. So if we take fruit beverages, They can be juices, concentrates, squashes, cordials, and barley waters. So we are going to talk about these things very briefly now. These are prepared from fruits. They have characteristic flavor, aroma, color, and palatable balance between acidity and sugar. So when we make these things, we are balancing the acidity level and sugar level, right? So that we get a very nice taste. Sometimes we use 2 or more fruits blended together. We can have mixed fruit cordials like juices. We can have unfermented or pure fruit juice. Without adding water, we can add like the pure juice, we can get it. Natural juice pressed out of fruit. Composition unaltered during preparation and preservation. So I'm sure you have seen those big bottles, say 100% juice with no added sugar. So those are pure fruit juices. Pure fruit juices without adding anything like sugar, just the pure juice. And if we talk about fruit juice based beverages, there are many types. It's a very broad term. So in making fruit juice based beverages, so before drinking, no, the fruit juice based beverages can be altered considerably. Like in making fruit juice beverages, the fruit juice composition is altered considerably. And sometimes we can dilute these beverages before serving. Sometimes we can dilute. It's a broad term used for various products. Fermented fruit beverages. So there is wine, beer is not made of fruit, but there is beer too, and apple cider, and then from pears also fermented beverages are made. So they have some alcohol percentage. And there are squashes, crushers, and nectars, different types of products from fruit juice. If you take squashes, they are used from strained juice, fruit pulp, and cane sugar. The specifications are given here. The juice content should be at least 25%. Total soluble solids, that is, the sugar content should be 40%. The acidity should be from 1 to 1.5%. And examples are given here: orange squash, lemon squash, etc. And fruit juice crush, similar to squash, but higher TSS, like similar to squash. Juice percentage, acidity, and everything like is there. The TSS is high. I think it's 50 or 55%, the sugar content. This is banana berry crush. And then there is cordial. So usually cordial should be clear. Cordial should be clear. I don't know whether that is the case in Sri Lanka, but usually cordial should be clear. Suspending material should be removed. The juice should be 25%, like in crush and squash. The TSS is low. It's 30% here. In squash, it was, I think, 40%. So examples, lime cordial, and we have now, they have blueberry cordial, ginger and something cordial, different types of raspberry, different types of cordials, pear and apple. So we have different types: mango, pineapple, mixed fruit. passion fruit, different types of cordials here. Now, this is squash concentrate. This is cordial. As you can see, now they have similar ingredients. Yes, similar ingredients. Here, they have not mentioned pectin here, but I think some cordials have pectin too. Some ready-to-serve beverages also have pectin. Pectin is a thickener. And this beta carotene is added as a colorant, natural colorant, and the other orange sugar, citric acid, natural flavor, beta carotene, permitted preservatives, and yeah, sugar likewise, similar products. And then fruit juice, barley water. It's like a squash. Barley water is like a squash. I hope you remember the specifications. Yes, juice 25%, TSS 40, and acidity 1 to 1.5%. This is like that, but in addition, it contains 0.25% barley starch. So if it contains 0.25% barley starch, that is called barley water. And fruit juice concentrate. So what is removed? Through heating or freezing. Heating, water can be removed. Also, there is a process called freeze concentration. We can remove water through freeze concentration as well. So it's before serving, it is diluted 6 to 7 times the weight of water. Here, the passion fruit juice sweetened. This concentrate contains passion fruit juice and cane sugar. So those are the ingredients: juice and cane sugar. It's a concentrate, right? And there are different types of concentrates: orange juice concentrates, lemon concentrates likewise. And fruit juice powders. Fruit juices are dried to a powder, and then so they are made a stable, less bulky, easy to handle material. I'm sure you have tasted Coleman's. So that's it's a fruit juice powder. So since it's a powder, it can be rapidly reconstituted to a high quality product, resembling the original juice, but some flavor is lost. It's not 100%, it's not like the original juice. Some flavor is lost in the process. Now there is an equipment called spray drying, and that is used to make fruit juice powders. Dried juices are highly hygroscopic, and because of that, now these powders can absorb water very easily, and because of that, when we pack them, we have to pay extra attention. Right. Lunch break, or we can have a short break and then come to do the work. Shall we have a short break, like about 15 minutes, and continue? What do you think? What do you think? That I'm going to talk about now in the first session.
Recording in progress.
We will briefly look at those techniques a bit more deeply, right? Now, first, I'm going to, now can you see the slide? Thermal processing.
Yes.
Right. So we are going to talk about thermal processing very briefly now. Now, thermal processing is, in thermal processing, we are using a combination of temperature and time. Normally, if we use a low temperature, we have to hold that temperature for a long period of time. Whereas if you use a high temperature, we can have to hold it for only a short time, right? So we have to look at how the microorganisms behave and how the different components of the food behaves at certain temperatures and times, because we want to kill the microbes having minimal effect on the food qualities. So we have to think of both the microorganisms and the properties of food, such as color compounds, flavor compounds, nutrients, like that. What happens to those things when we increase the temperature or when we give a thermal treatment? So the term thermal refers to processes involved in heat, and then involving heat, then heating food is an effective way of preserving. The purpose of thermal processing, one is to reduce or destroy microbial activity. Most of the time, that is the reason, right? To reduce or destroy microbial activity. Number two is to reduce or destroy enzyme activity. So number three, to reduce physical or chemical changes. So to change the color, to change the texture, like that. Certain quality standards. Now for foods, there are quality standards. For different foods, there are quality standards. Because normally even at SLS standards, right? Usually now it is given that this food should have the microbes of this type should be less than this amount. Like that is indicated in those standards to make the quality of food meet certain quality standards. We have to sometimes give thermal treatments. So types of thermal processing, there are various types. So we can identify three main temperature categories employed in thermal processing. One is blanching, sterilization, and pasteurization. Now, blanching is not really a thermal processing technique. Blanching is a pre-treatment. That is a treatment given before proper processing techniques. So we told that blanching is done before dehydration, before canning. Okay, so it's a pre-treatment, not a processing techniques that can stand alone. And sterilization, pasteurization. So in those techniques, we are using steam or water. And there are different, like some other techniques that use hot air. Examples include dehydration, baking, and roasting. Dehydration, baking, and roasting. These techniques use hot air. And also, we can use hot oil for frying. So that is a different thermal processing technique. So let's look at blanching now. As you can see, from boiling water, these vegetables are put in ice cold water. So blanching uses boiling method to so it's partially, it is partially cooked. We don't want cooking to take place, but it is partially cooked, right? It's a quick way to destroy enzymes, keeping the food properties. It's a preliminary process to other methods such as deep frying and dehydration techniques. Product shelf life is short. So if we use blanching alone, then the product shelf life will be very short because it is not actually a single solo thermal processing technique. So the main objectives of blanching is first to destroy the inactivate enzymes and then to reduce the microbial load. So because we are blanching, because we are giving a heat treatment, like the microbial content of the fruit, the vegetable is going to go down, right? The microbial count is going to go down, and that is helpful because if we are going to use it for some other purpose, we can use mild conditions because now the microbial count is low. We can use mild conditions when we go to use proper preservation techniques. But the main intention is to inactivate enzymes. Now, methods of blanching. So these things were mentioned previously: steam blanching and hot water blanching. Steam blanching and hot water blanching. In steam blanching, 30 to 90 seconds, we have to expose the vegetables to steam, and then if we use steam blanching, the nutrient retention is high because if we take hot water blanching, the nutrients go to the water very easily in hot water blanching. The nutrients go to the water, right? But if we use steam blanching, that does not happen. Because of that, the nutrition retention is high. And for steam blanching, steam blanchers are used. And in hot water blanching, hot water is used, and the vegetables are dipped in hot water for 1 to 5 minutes. So now I told you that after blanching, whether it's steam or hot water, we have to cool it. After blanching, that can be done using hot water or cold air. So pasteurization. The main aim of pasteurization is to kill disease-causing microorganisms. The main aim is to cause disease-causing microorganisms. At the same time, the spoilage microorganisms also get killed. So pasteurization is actually a milder treatment than sterilization. In pasteurization, it does not kill all the microorganisms. It kills pathogenic microorganisms, but not all microorganisms. The viable pathogens, the number of viable pathogens goes down, and enzymes, the enzymes that cause milk spoil will also can get destroyed. And because of that, pasteurized milk is drinkable for we can't say for a long time. I will change this. Well, for a longer time than fresh milk. Pasteurized milk is drinkable for a longer time than fresh milk, but that time is not that high. If we sterilize, we can use milk for a long time, but not when pasteurized. After pasteurization, normally we have to keep the milk in the fridge also. We can drink it. It's drinkable for a longer time than fresh milk, but for a much shorter time than sterilized milk. So if we take milk, there are different types of pasteurization: low temperature, long time; high temperature, short time; and then ultra high treatment or ultra high temperature. I'm sure you have seen these letters UHT on the Tetra packs that we get for fresh milk and other flavored milks. UHT, that's ultra high treatment. In this treatment, it's a pasteurization method, but the temperature goes up to higher than 100 degrees, and it is kept there for a very short period of time, 1 second or a few seconds. I don't exactly remember, 1 or few seconds. For a very short time, we are keeping the milk at that temperature. Low temperature, long time. So low temperature 63, long time 30 minutes. But the food properties actually get affected very much because we are using this heat for a long period of time. It's used for milk to prepare cheese, yogurt, etc. And average shelf life is about 7 to 10 days. And high temperature, short time. So we are using a higher temperature, 72 degrees for 15 seconds. So the shelf life is between 16 to 21 days. Now let's talk about sterilization. It's a controlled heating process used to completely eliminate living organisms, including thermoresistant spores in milk or other food. So it can be achieved by many ways. That means we can use moist heat, dry heat. We can filter and get rid of all the microbes. And then we can, as I mentioned previously, we can use irradiation or by chemical methods. But using chemical methods is not advisable because we don't want to consume much chemicals with food. So chemical methods, actually, if we can use some other techniques, we should go for other techniques. So food products filled in sealed containers are exposed to temperature above 100. Usually 110 to 121 temperatures are used. Because if they to destroy Clostridium botulinum, I think we have to use 121 degrees Celsius. Well, we have to think of something now. The food is in a container, in a can, let's say. So we have to make sure that the food inside, that the temperature, the heat reaches the food, the center of the package, and all the parts of the food get that high temperature. We have to make sure that it happens. Otherwise, the microbes in those areas that temperature was not that high will grow, and then it will be problematic. Heat must be reached inside the product. And products are kept for a defined period of time at that temperature level for sterilization. So it depends on the type of product and size of container. Right.
Recording stopped.
Okay, now we are going to talk briefly about dehydration, fruit and vegetable dehydration. So dehydration is the application of heat under controlled conditions to remove the majority of the water normally present in food by evaporation. Okay, I'm going to use my other container, other computer. Is we are using controlled conditions. Can you hear what I say?
Yes, madam.
Right. We are using controlled conditions. That is where we can temperature the time, airflow, and humidity. So that is dehydration. So drying is the broader term. So drying covers a lot of things, including dehydration and many other things, right? Drying. But in dehydration, we are using controlled conditions. So sun drying is not dehydration, right? There are separate dehydrators that we can use for dehydration. So you can see some pictures of fruits that have been dehydrated. So the purpose of dehydration, of course, to extend the shelf life of foods, and we do that through by dehydration through removing water. We are bringing down the water activity, and also because of that, the microbes can't grow easily on dehydrated foods. Of course, if they absorb moisture, then microbes can grow. And also enzyme activity is lowered because there is no moisture now, almost no moisture in the dehydrated fruits. And so now in dehydration, the volume and weight goes down. So if we take 1 kilo of apples after dehydration, the volume, the weight would be much lower than that. 1 kilo will be something like 150 grams or 200 grams, let's say. And also the volume becomes much less because of the removal of water. Because of those things, we can efficiently transport and store the apples. So drying versus dehydration. So drying is a broad term that I mentioned previously. So it involves non-conventional energy sources as well, such as sunlight and wind. In dehydration, it is different. It is done in particular equipment. Then dehydrated mango is, you can see in the picture on the left-hand side, you can see dehydrated mango. And I told you now, drying can be not dehydration. It can be freeze drying as well. In freeze drying, what we do is we don't use high temperatures. We freeze the foods, and then the foods undergo dehydration. So the quality is the quality of freeze-dried material is much higher than the quality of the dehydrated material. And it is very clear on the picture on the right-hand side. There is a picture of dehydrated banana, and a freeze-dried banana. So the freeze-dried banana is closer to the original form. So dehydration, it's the process of removal of water from the food under the controlled conditions. The controlled conditions, that is temperature, relative humidity, and airflow. So this is a comparison of sun drying and dehydration. So sun drying involves conventional methods. Dehydration involves mechanical methods. Sun drying is carried out in open natural conditions, but dehydration is carried out under controlled conditions. So sun drying is non-revisable. We can't revise anything. But dehydration is revisable. We can adjust the temperature. We can change the flow rate, airflow, humidity. We can actually change these things. It's revisable. And sun drying. Sun drying leads to high nutrient losses, but in dehydration, we can minimize that. Sun drying is cheaper because now we don't have to spend much. We don't have to spend anything on the equipment or fuel. So sun drying is a very cheap method, whereas dehydration is costly. So sun drying usually takes more time because we can't use high temperatures or we can't have high flow rates. It depends on what is there, right? So it takes more time. So dehydration takes less time. The source of energy required is freely available, sun drying. Source of energy is costly in dehydration. So the process of dehydration, so we have to take vegetables or fruits, wash, prepare pre-treatments such as blanching, spread on trays. We have to do dehydration treatments, then packing and storage. Methods of dehydration. We can do sun drying, as I mentioned previously, and we can do artificial dehydration. We have to do, well, there are certain pre-treatments that we can do. Examples include blanching, salting, or adding sugar. We can do those things as pre-treatments. Other than that, we can use smoking for dehydration. It is done for, I think, meat products, fish. Smoking is done, can be done prior to dehydration, drying. So sun drying. So now sun drying is kind of okay for fruits because they have high sugar and acid content, and because of that, microbial growth will be slow. But sun drying is not actually recommended for vegetables and meats because there is no acid or there is no sugar, but it is done. Anyway, it is done. So conditions needed for outdoor drying are hot, dry, breezy days, minimum temperature of 30 with higher temperatures being better, and humidity below 60. And it will take, of course, several days. So blanching. So we learned about blanching. Under thermal processing, I don't want to then take much time on blanching here. What I want to highlight here is that sometimes to blanch water, we add sodium bicarbonate and magnesium oxide. That is to retain the green color of green vegetables. So for dehydrators, You can see two pictures of dehydrators. Yes, as I mentioned previously, for vegetables, meat and fish, it is advisable to use dehydrators. However, sun drying is done. That is in practice. Okay. So dehydrators now, kitchen scale dehydrators are indicated here. So we can regulate the temperature, airflow in these dehydrators that we get. We can actually have these things in our kitchens. Okay, now we are going to have a brief look at preservation by adding chemicals. Food preservation. You know what food preservation is. We can do it through two or more methods, physical methods and chemical methods. Also, we can use microbes in fermentation to preserve foods. So chemical preservation includes adding chemical compounds to the products. So if we are doing direct additives, we call it chemical preservation. The most important thing is that we have to use the correct dosage of chemicals. We can't use like a higher amount. Usually the authorities of different countries give guidelines. For example, US Food and Drug Administration specifically indicates that this chemical should be put in this concentration. Likewise, I'm sure in Sri Lanka also there are guidelines like that. So there are traditional preservatives such as sugar, salt, vinegar, and alcohol. We talked about these things. And there are many acidulates such as lactic acid, even citric acid, other types of acids. Also benzoates and sorbate. They can be acidulates, and there are other benefits rather than reducing the pH of the food, right? Using benzoates and sorbates. And also there are gaseous chemicals such as carbon dioxide or sulfur dioxide. Sulfur dioxide is usually present as sulfides, and antioxidants are there. So there are natural preservatives like salt, sugar, alcohol, vinegar. And then yes, salt and sugar are the earliest natural food preservatives which drop the growth of bacteria in food very efficiently. Sugar and salt, as I mentioned previously, the amount of water available for the growth of microbes go down when we add sugar and salt. Also, osmotic pressure goes up when we put salt and sugar in water, and because of that, the cell growth of microorganisms is inhibited, or it can be completely destroyed. Sugar is used in many food items such as jams. Salt is also used, especially in fish and meat. There are acidulates. So there are, like, chemically we can put acidulates. Also, acidulates are formed during fermentation. For example, acetic acid can be formed and lactic acid can be formed during fermentation. Benzoic acid or benzoate is a antimicrobial agent that we use in foods. The structure is given here. It's benzoic acid, the structure of benzoic acid. When it is a salt, it can be sodium benzoate, potassium benzoate, like that. So the level that is used, benzoates range between 0.05 to 0.1%. That is, about 1 gram is used for 1 kilo. So lactic acid, it is formed as a result of fermentation. When we talk about yogurt, lactic acid is formed. So because of that, the environment is unfavorable for the microbes. Then sorbic acid. Of course, sorbic acid can be put as an acid or a salt. In the case of a salt, it can be potassium sorbate or sodium sorbate. So when it is used at concentrations less than 0.3%, it doesn't give a bad effect, but normally 0.1% is used, like 1 gram for 1 kilo. And then sorbates are used for moles, and yeast inhibition is in a variety of foods. Yes, it's used in the range of 0.025 to 0.1%. It is used in many foods such as cheeses and breads. Gaseous chemical food products include carbon dioxide, nitrogen, and sulfur dioxide. Sometimes the use of sulfur dioxide is limited because of the health effects on humans. Antioxidants. An antioxidant is usually a chemical preservative, vitamin, or phytochemical. So I told you that in order to prevent lipid rancidity, we can put chemical preservatives such as BHA, BHT. We talked about it. Vitamin or phytochemical. It neutralizes damage to the foods and are naturally present in vegetables, fruits and grains, and nuts. It's beneficial in preventing rancidity in fats and foods containing fats. Here I have given examples: BHA, BHT, vitamin E, vitamin C. Now these are antioxidants used in foods. Advantages of adding chemicals. Chemicals improve the shelf life, that is the length of time that it is safe to eat, and it improves the organoleptic qualities, flavor, appearance, color, aroma of the food. Sometimes chemicals, and increase the nutritional value. That is not chemical preservatives, rather chemicals, right? Chemicals can increase the nutritional value. We can put chemicals to increase the nutritional value. We can improve the chemicals to improve the organoleptic qualities. That's the appearance and the taste and aroma, things like that. It's much wider variety of foods is available. Additives, that these are not chemical additives, rather, right? So if we put chemical preservatives, they can improve the shelf life of foods. Additives allow consumers to store food for longer periods, which means that the frequency of buying food can be reduced because chemicals extend the shelf life of foods. Then we don't have to go to the shop that much. There are disadvantages of adding chemicals as well. Well, it can affect human behavior. So it has been observed in rats. We don't know whether we can extrapolate it into humans, but behavioral issues can be there. Some people, children can have allergic reactions, potential links to cancer, not yet unproved, linked to asthma, can be many toxic effects and contribute to high blood pressure. Right. So, yeah, are there any questions that you have? Right. So we talked about fermentation at the first part of this session, but we will have a brief look at fermentation also. So fermentation is a metabolic process that produces chemical changes in organic substrates through the action of enzymes, of microbes. So you can see this picture, all are pickled items by the action of, using the action of microbes. So there are different types of fermentation, and now we will look at lactic acid fermentation. So the fermentation which lactic acid is produced is called lactic acid fermentation. Yogurt production, curd production, and several pickles, production of several pickles is a type of lactic acid fermentation. So chemically what happens is that glucose is there and then it is converted to lactic acid in lactic acid fermentation. And then there is alcoholic fermentation. The alcoholic fermentation usually occurs during using yeast. So in wine production, beer, cider, like that, we usually yeast is used for alcoholic fermentation. So alcohol and carbon dioxide are produced. For ages, products are made and stored using the process of fermentation. Beer, wine, pickled food. So cheese comes under lactic acid fermentation. I will remove that. Wine, beer, pickled food, and bread are produced as a result of fermentation of food items. So alcoholic fermentation is chemically represented as glucose is converted to ethanol and carbon dioxide is produced. Acetic acid fermentation. Acetic acid is produced by fermenting various substrates. We can use various substrate, starchy solutions, glucose solutions, or alcohol, foodstuff, such as wine or cider with acidobacter bacteria. Now, in acetic acid fermentation, it starts with alcohol. So we can use wine or cider and use acidobacter to produce acetic acid. Or else, if we are using a starch solution or sugar solution, first we have to convert the sugars into alcohol, and then alcohol has to be converted to acetic acid, right? So examples are apple cider vinegar and wine vinegar. So how does fermentation preserve food? So desirable bacteria cause less deterioration of the food by inhibiting the growth of spoilage bacteria. Some fermenting processes lower the pH of foods, preventing harmful, so some ferment like lactic acid fermentation and acetic acid fermentation, they lower the pH of the food, and because of that, harmful microorganisms cannot grow in that environment. Controlled fermentation processes encourage the growth of good bacteria, which stamps or fights off the bad microbes. So, for example, like in yogurt, because there are microbes in yogurt, they are called probiotics, right? Microbes are there in yogurt, and because of those microbes, other microbes can't grow. So these are some examples of fermented foods. You can actually go to the internet, use YouTube, and look at these types of fermented foods. You can get to know what these things are. Microorganisms involved in fermentation. There are various microorganisms that are involved in fermentation. Examples include yeast, molds, or bacteria. So in pickle is an example of fermented product. So what happens is that we put brine, that is salt solution, and it encourages the growth of lactic acid bacteria, and lactic acid bacteria produces lactic acid. So we get a sour taste. So we can use lactic acid or acetic acid fermentation in using pickles. And there are many industrial applications, alcoholic beverage industries. So we can produce wine and using grapes, apple cider using apples, and berries can be used. Rice can be used. When rice is the carbohydrate source, we call it sake, and many other substrates can be used to prepare alcoholic beverages. Any question? Any question? Yeah, if you don't have a question, I think we can stop this lesson. I have few more slides. I have some slides prepared for pickling and juice processing. I will not test you on that, but anyway, I will upload the slides on LMS, right? So you're welcome.
Thank you, madam.
You're welcome. So I hope that you understood all the things that we talked about. I'll upload the slides on LMS, right?